Good day, class. Hope you're all fine. In our last discussion, we talked about trigonometry, the Pythagoras theorem. By God's grace, today we'll be discussing measure of angles. But before we enter the discussion properly, I would like to write the objectives of today's class. Behavioral objectives. We'll be discussing one, measure. At the end of this class, we should be able to know the measure of angles. Two, we should be able to understand how many degrees make a complete revolution. One complete revolution. We should be able to relate degrees and radians together with one another. Relationship between degrees and radians. Relationship between degrees and radians. Relationship between the length of an arc and the angle made with the center of the circle. These are what we are going to be looking into in this class. Measure of angles, one complete revolution, relationship between degrees and radians, revolution between the length of an arc and the angle made with the center of the circle. Now let's begin with the measure of angles. Measure of angles. When we say angle, we have several types of angles. We have acute angle, we have obtuse angle, we have many angles. We have reflex. Okay, so we have several types of angles. But we will use a particular angle to test for the direction of angle. Angle can only move in two ways, in two directions. We have clockwise direction and we have anti-clockwise direction. So when angle moves in an anti-clockwise direction, what will be the value, the sign? Will it be positive or negative? When it moves in clockwise direction, what will it be? Will it be positive or negative? We are going to look into that in the concept of measure of angle. Now, if we have angle in clockwise direction, angle in clockwise direction has a negative value. Angle in clockwise direction has a negative value. So angle in anti-clockwise direction, of course, has a positive value. So it should be noted here that when we are moving angle in clockwise direction, the sign will be positive, but when we are moving it in anti-clockwise direction, the sign will be negative. Let's take, for instance, here, if I have a circle, if I have a line, a straight line, okay, and we know that angle on a straight line is 180 degrees. Angle on a straight line is 180 degrees. So I have this perpendicular line that makes it 90, 90. And of course, 90 degrees plus 90 degrees is 180 degrees. So if I want to bring out obtuse angle, which is angle greater than 90 degrees but less than 180 degrees, I'll have something like this. Let's say this is 30 degrees, for instance. It's not drawn to scale. And this is 90 degrees. This place is 90 degrees, as we can see. But if this angle is moving in anti-clockwise direction, as I said, angle in anti-clockwise direction has a positive value, but angle in clockwise direction has a negative value. So if I move this in anti-clockwise, this is anti-clockwise. Clockwise direction means the way clock moves. You know, clock moves, the hand that reads the seconds and the one that reads the minutes, the one that reads the hour, they all move in this format. This like this, like this. That is what we call clockwise direction. But if it is anti-clockwise, it will move in the reverse order. So if we are moving this angle in this order, this is what we call anti-clockwise. So it definitely means that we are going to add this 90 plus 30 degrees to give 120 degrees. And this angle, let's label this P, let's label this O, and let's label this side X. So angle POX equals to 120 degrees because it moves in anti-clockwise direction. So, but when we want to write this, when we want to create an angle that is moving in clockwise direction, let me give another example. Let me use acute angle. This is an obtuse angle because it is greater than 90 degrees but less than 180 degrees. But an acute angle is an angle that is less than 90 degrees. Now, for example, if I have, let's say I have something like this, for instance, and I have something like this. So if this is an angle, if I am moving this angle like this, you can see it is clockwise direction. So, and I label this P, I label this O, and I label this X. This angle, we're not trying to scale now. Let's assume it is 45 degrees. But because it is moving in clockwise direction, it will not be positive. It will surely be negative. So angle POX equals to minus 45 degrees. The reason is not far-fetched because the movement of the angle is in clockwise direction. So that is what we will be discussing on the measure of angles. Angles, we can measure it in terms of clockwise or anti-clockwise direction. So if it is clockwise, it means that the value of the angle will be negative. If it is anti-clockwise, definitely the value of the angle will be positive, as we can see on the board. Now, we've discussed that obtuse angle is an angle greater than 90 degrees but less than 180 degrees. We've also discussed that acute angle, this is an example of acute angle, an angle less than 90 degrees. Now, another thing we want to discuss here is one complete revolution. When we say a complete revolution, it is the totality of the circle, the angle made with the totality of the circle, that is 360 degrees. Now, one complete one complete revolution equals 360 degrees. 360 degrees. So a complete revolution equals 360 degrees. Even in geography, we have revolution of the earth, the revolution of the earth, where revolution of the earth makes it's what brings about the year, the 12 months in which we count yearly. So 365 days. It takes the earth 365 1/4 day to revolve around the sun. So the same thing is applicable when we are talking about revolution. So within the if we assume that the center of the circle is O, it takes that it takes the angle about 360 degrees to complete to complete one revolution, and one revolution is nothing but 360 degrees. So let's go to the next thing we have in our objective today. We have relationship between degrees and radians. How do we relate radians and degrees together? Radians and degree. Of course, we have two notable ways in which we can solve angle. We can solve angles in terms of degrees or the units. Let's say the unit of angles. Angle can be the unit of angle can be in degrees and it can be in radians. So we want to look into how this degree relates with radians and how radians relate with degrees. Now, relationship between radians and degrees. Now, let's say we have a circle with a length of an arc equal to the radius of the circle. The length of an arc is equal to the radius of the circle. What am I saying? Let's say we have, this is a circle, this is the center of the circle. Of course, the radius of a circle is the line drawn from the center of the circle to any part of the circumference. We have these. Let's say this is the radius. You know, if I draw another line to meet the circumference, that particular line too will represent a radius, as it is defined as the line drawn from the center of the circle to the circumference, to the line of the circumference. Now, if this is this is the radius, this is another line which we can call radius, and this is, let's say, S, T, and this is center O. This line, let's label it L. This L is called the length of an arc. Length of an arc, ST. The length of an arc, ST. Now, if we have this length to be equal to this radius, if ST equals R, that is the length of the arc is equal to the radius, that is the line drawn from the center to the circumference, then we say that this is an angle. We say that angle theta, or angle SOT makes, let me use this place. We say that angle SOT makes 1 complete radian. Radian makes one complete radian. So if the length, let's say this is a unit, this is another unit. So if we have this length of the arc equal to the length of the radius of the circumference, then we say that the angle SOT makes one complete radian. Now, but if we have similarly, if we have another circle of like this, we have another circle, we have, let's say this is the center of the circle, this is a radius, then we have another line drawn like this, we have A, we have B, we have O as the center, we have the angle made to be theta. Of course, you can see that this length of arc, let's say this is the length of an arc, let's say the length of an arc is S, for instance, as we labeled it L here. You can see that the length of an arc here is bigger or greater than the radius of the circle here, unlike this that we said it made complete radian. So here, if we want to relate the theta in degrees with the radian, we say that angle AOB equals to the length of an arc, which is S, over the radius, over the radius. And of course, if we look into this particular one we did, that we said, we say that angle SOT makes one complete radian. Using this formula, we say L over R. If we have L over R, and we say the length L is equals to length R, L over R will definitely be 1, and that is what makes us to say one complete radian. L over R is 1, and that is one complete radian. So in this case now, S is bigger than R, S is greater than R, so we have SR radians. So this is how we relate the degrees with radians. This is how we relate the degrees with our radians, S over R. Now, I made mention of something, complete revolution, in our second objective of the class. Now, how do we now get a complete revolution? How do we get a complete revolution from this concept? Now, having known that to relate an angle measured in degrees to radians, this is the principle, the length of the arc over the radius of the circle. Now, if we now have the circumference itself as the arc, the circumference as the arc, now, which is the circle itself, what will be the radian in radians? What will be the result in radians? We have one complete revolution is then given as is given as length of the circumference all over the radius. Length of the circumference all over the radius. So we have length of the circumference equals what? 2 pi r, which is the formula for the circumference of a circle all over r, we are relating it with the radians. So we have 2 pi r over r can cancel r. So we have 2 pi radians. 2 pi radians. And of course, one complete revolution we discussed the other time, we said equals what? 360 degrees. 360 degrees. Now, the relationship between the length of an arc and the angle. So this is the length of an arc and the angle. And this is the complete revolution is given as 2 pi radians equals to 360 degrees. Now, what is the relationship between the length of an arc and the angle made with the center of the circumference of the circle? That's we've done. But let me quickly explain this. You know, most times we always say 180 degrees equals to 2 pi radians. How do we get that? So if we have from that place 2 pi rad, rad is the short form of writing radians. 2 pi rad equals to 360 degrees. Then we can say pi rad equals 360 degrees over 2. Then pi rad equals to 180 degrees. Can you see how we are relating radians and degrees? So far we've discussed measure of angles, we've discussed complete revolution, we said it is 360 degrees. We made mention of relationship between degrees and radians. We explained by constructing the diagram and explaining how we came about the complete revolution of a circle. We said it is 2 pi radians by relating it with the length of an arc, which we have given previously. And lastly, we ascertained that the formula pi rad equals to 180 degrees. This is where our class ends. Please don't forget to subscribe to the channel, watch and like our video. Thank you.